let's talk about the fundamental theorem of algebra. So this touches on something that we saw recently about how, like, a linear polynomial, like maybe x minus 1, has just one factor, so one solution. A x squared minus 4 could be like x plus 2, x minus 2, two factors, two solutions. I'll make a table here. And a third degree polynomial like x to the third minus 4x can factor into like x plus 2, x minus 2. That can have three solutions, 0, -2, and 2. And so on. In general, if you've got an nth degree polynomial, then you'll have like n factors, so n solutions. Now there's some caveats to that, but the fundamental theorem of algebra is that for an n degree polynomial, you're going to have n solutions in the real n complex numbers, counting repeated solutions. So yeah, that's kind of a mouthful, but lots of caveats. But it's actually not too much more to remember if you think about complex numbers and repeated solutions. So let's talk about complex numbers first. No, let's talk about repeated solutions first. So repeated solutions would be something like x squared plus 2x plus 1. This factors into x plus 1, x plus 1, like x plus 1 squared. So the solutions are just x equals -1. But it comes from two factors, so you can count that as like -1 and -1 again. So that's what we mean when we say n solutions. We mean that really like n solutions counting the same solution twice if needed, just coming from the factors. Also, something like x squared plus 1, that can factor into x plus I, x minus I, where I is the imaginary unit. So we're also including complex numbers in this as well. So n solutions, and then star including complex numbers and including double counting, or triple counting, or quadruple counting. In other words, that's the multiplicity of a's there. So in this case, -1 has multiplicity -1 in this equation, or -1 has multiplicity 2 in this equation, because there are two of them that appear. Let's do one more example of this. Let's do, how about, hold on, let me work this out on paper really quick. A good one. So let's do x to the 4th minus 1. So according to the fundamental theorem of algebra, this thing should have 4 solutions. Well, the equation x 4th minus 1 equals 0 should have 4 solutions, meaning that this polynomial should have 4 zeros. So we can factor this as x squared plus 1, x squared minus 1. Now, this thing we can factor as x plus I, x minus I. And this thing we can factor as x plus 1, x minus 1. So the solutions here are, or the zeros are x equals negative I, negative 1, and 1. Cool, that works out. We've got 4 zeros, including these imaginary zeros here. Let's do, okay, I got one. Analogous one. We'll just put it on the side. So, how about x to the 7th minus x to the 3rd? So this is just like this one, except everything's multiplied by x cubed. So you can do x cubed, x4 minus 1. Actually, before we go on, we know we should have 7 zeros, because that's 7th degree. So if we factor this like we did here, that's a 4. X cubed, x plus I, x minus I, x plus 1, x minus 1. Then this solution, we've got minus I as a solution here, I as a solution here, minus 1 solution there, 1 solution there. And then this one has solution 0, 0, and 0, because it's repeated 3 times. So that's like, you can think of that like x times x times x. X to the 3rd is like x times x times x. So each one of these has solutions 0, 0, and 0. So altogether, that's 7 zeros, even though we're triple counting the 0 here, and we're using some imaginary zeros there.